Hey, Pack Leaders is here
Hi.
with friends and I, protecting families, protecting Pack. I have my boy Evan here. He's going to be joining us in our video. He's waiting for me to finish so he can go rollerblading with me. So I want to talk about a journal of programming. So
Wait, what? You wanted to do that then?
Yes, that's what I want to do. I just want to share my journey in programming here. Kind of like when I first started, I didn't know where to start. So I kind of did some chicken scratch here. I don't know if it helps you or not, but just kind of brainstorming how I want to organize my nodes. And then realizing that, hey, even though I have all this stuff, when you actually get into the nitty gritty of it, you actually need to build some kind of configuration file. So my GitHub on
And I'm
github.com.
playing for us to go in the wild so we can shoot a lot of deers.
Okay, yeah, you're gonna be quiet while I'm talking. Okay, all right. So I have this configuration file set up here. It's public. Maybe you just go to github.com/hinquark. I kind of created some in this configuration folder, and I just kind of show you this is kind of where everything's at right now. I don't have anything kind of planned out, which is okay. And I know that you can't think of everything up front right away. So just kind of going off of this PDF here of how to organize the genome. There's this big overall block here, and the inside here there's node genes and connection genes. Let's start with connection genes because it has a little more information in there. There's input of what node is coming from, what node is going in, what node is going out to, the weight, whether this connection is enabled, and the innovation number of each connection. Okay, and they could be turned on and off, I believe. I don't know if this is a typo, but I think there should have been some more innovation numbers. But anyways, something I need to learn about for it to be clear. So anyways, knowing these inputs, they're basically just setting up global variables for what I'm going to pull. So I have the connection name, connection number, input node, output node, the weight, the status, and the innovation number. So basically this configuration file is basically setting up global variables so that I can pull those in and use them as a standard. If anything ever changes, I can then update this, and which is why the configuration file can break everything. But it's also a way to kind of organize all your global variables into one place. So what's after that? We're going to look at the node. That's the one right there. Node number, node type, node value, and the position of the node, which they don't really give us. But I've noticed from watching other people program is that we're going to have to know the X, Y, and I'm going to do a 3D Z location of the nodes so you can actually animate them and visualize them as you place them and then connect them up. So we're going to put them in some kind of a animated 3D format kind of thing, and I plan on doing that. So they don't give you that stuff, but you can add whatever you want to it. The document here for Neat is very short. It's only like 2 or 3 pages. And it kind of just basically gives you the idea, the concept, but they don't give you every little detail on how things are, or how to do things. So you're gonna have to think about it. You get the idea, get the gist of it, and they're not gonna tell you what to do. And you're gonna have to do a lot of thinking, take a lot of showers to think and plan this all out, and then just kind of encounter the problem as you go and build it as you need it. So once I have the connection gene and the node gene, I then will put the connection gene into a list to have a list of all the genes, node genes, and then a list of all the connection genes. And then we're going to have some methods here. These are just names for now. They don't really do anything. But maybe there's something where I can put a selection where it can decide to launch the mutation of the link, mutation of that. So basically it's kind of like allowing to pick which method to run based on some kind of random thing, or maybe I'll have a set of neurons control it. I don't know, but that's all not clear yet. But I just know that it's okay to put it in there. It just helps me plan things out, and I can pull those things later on. Okay, so hopefully that helps. This kind of helps me talk it out and plan things out. So my next thing now is to be able to connect to it via Bybit API and actually pull and create a neural network, which I'm going to store in this master genome. It's just a blank file right now, but it's going to contain basically something similar to, let me see if I can show you this. The object gen. I've been using this tool to help me plan. If I can find it. Maybe I can just go to it. Here it is. Object gen. Oh, it's not popping up. OBG object gen. Huh. Okay. I'll just go to it. Anyways, I think it saves some of my stuff. Alright, so kind of like this, but since I have a gene list, this would be kind of like my innovation number here, node 1, and then I'll have, you know, something else in there, such as node number, node input, connection input. I might be botching this. I'm supposed to put this in maybe in the connection gene that has more information. Node input. That could be 1 or something like that. Node input output. Maybe 5, it connects to 5. And then some other information, whether it's activated, node activated or not, or connection activated. And then that will kind of give you some information what's going in, what's going out, the connection weight. And that could be some random number. Right? And then what's going to happen now is that this is going to repeat itself. So then this would be maybe my next node, 3, 4. So this would be my database that kind of tracks all the nodes I have. And since there's like 4 nodes I'm talking about here, there's probably going to be, you know, a node here, node number 1. And I'm just going to generalize this for now and not really complete the nodes, but just to give the gist of what I'm trying to get at. So there should be node 2, and node 3, and then there should be node 4. And then in that node 1, 2, and 3, and 4, it's going to have a certain thing to like node name, and it's going to repeat itself. And this would be like maybe price, maybe, or something like that. So there's inputs of price, there's input of you know, VWAP maybe, no name, it goes VWAP, and then I could probably give it there's going to be a value coming in, right? So it'll be VWAP price, maybe like 1,343, whatever it is, and then current price, node value, and that could be the current price of, you know, 1,345, something like that. So hopefully you get an idea of what's going in, what's going out. I can then track and say, hey, that's coming in, so I'm going to get this value here, do some computation, multiply it by this number, and then send it out to node 4, or do a connection there. I'll also have the X and Y. So then over time, you'll be able to see this on GitHub. I'll have basically a version controlled of all the neurons, in the sense as a database. And I notice that databases don't really version control. At least the MongoDB doesn't do. They have a slight, somewhat MongoDB version control of that. And I am limited to 100 megabytes per file, so I have to make sure that I track the size of this, and if it does exceed 100 megabytes, I need to, you know, spin up a new file, and I shouldn't have any limits on the number of files I can have. So all that's going to go into the master genome 0 neural network.nn, and that will be public, so anyone can just, you know, branch off from this, create their own genome, test it, and as it branches off, it's going to test and back test on previous data. And once that's done, then it can say, hey, this is the best one, and then we can then test it, and if it goes well, then we can then, you know, maybe merge it back into the master genome kind of thing. Okay, so at least that's the idea. That's kind of how I'm planning it out. I can branch out, I can kill off what I don't need, and then merge the best one back into the master. Okay, now I think there could be multiple masters later on, or there could be, you know, all kinds of stuff, but I'm not gonna think about that right now. There might be, you know, master genome 1, master genome 2, master genome 3, and they can all have their own separate strategies, I guess. But then they can breed against each other, and then maybe we'll pick a supreme master genome or something like that later on. Okay, so that's all I have for now. Now it's just kind of making the connections and figuring out how to pull the API in. I figured that out already, how to pull that data out via API. And now we got to figure out how to publish it and put a comment and kind of commit it back into GitHub. Once I make all those connections and set those methods aside, then I can start maybe tying things up together and finish up plumbing. Okay. All right. So I think that's all I have for today.